Well, hello again everybody. Well, this week we're going to be continuing our holiday from valve radio repair, and instead we're going to take a look at this Katsu hydraulic punch set. So I'm sure that some of you are wondering why I actually purchased this hydraulic punch set, and as usual I don't really have a very good reason, but it's fair to say that there was alcohol involved, which in my case really isn't unusual, is it? Now, just for a change, rather than buying the punch set from eBay, I actually purchased this from Amazon Prime, and the actual seller was AIM Tools Limited, who were a distributor in the UK. Now, the unit that I've bought does say Katsu on it, but I think a number of these units probably all come out of the same factory in China, so you will see a variety of names on them. So this is Katsu. The other one I've seen is MosaicAL, and there's another manufacturer or another brand of this called Vevor, but I think they're all the same. Now, you can also purchase this off eBay and from places like Harbour Freight, so it's available from a number of different vendors. In the case of this one, I actually paid £69.99, and that included the Amazon Prime delivery. Now, as you can see, this particular punch set, I've actually bought it in a metal box. Again, you can buy the same thing in one of those plastic blow moulded cases. For my personal experience, I don't really like those plastic cases because the contents of them never fits properly, and the hinges always fail on them relatively quickly, and also it can often be difficult to fit the parts back into the blow moulded case. They never fit very well, so I just thought it's easier to have a metal box and you just throw everything back inside. Okay, let's open the box. There we go. The set that I've bought just come with 1, 2, 3, 4, 5, 6 punches, and the range of punches goes from 22mm to 60.5mm. Now, you can actually buy this set in a number of different punch sizes, and you can also get bigger punch sizes, and they can come in a set between, I think it's about 63mm to a maximum size of 114mm. So let's just unpack the box and see what we've got. So right away at the bottom of the box I can actually see that this set comes with a set of replacement seals. I don't know if that's a good thing or not. Are they trying to tell us something? But I guess we'll put them on one side for safekeeping. Hopefully we won't need them for some time. It looks like it comes with some spacers, hollow spacers. Ooh. And here's the actual hydraulic punch head itself, which is basically a hydraulic ram. And what this will do is it will actually operate these punches to punch holes in things. That's actually quite a bit heavier and more substantial than I thought it was. Now, from memory, the capacity of this ram, I don't know if it says on it, but I think this set claims to be a 10-ton ram. Let's see if it's got anything written on it. Okay, so our little ram here, it doesn't actually have the tonnage written on it. It does actually say that it's got a maximum stroke of 22mm. The maximum cutting thickness in stainless steel is 1.6mm, but in iron it goes up to 3mm, and the punching range again is between 22 and 60mm. And amazingly enough, it does actually have a UK address on it, so it does say Made in China for Katsu Tools Limited, 262 High Road, Harrow, HE3 7BB. Yeah, but that's actually quite a lot heavier and more substantial than I thought. Now, I've got to admit, I'm not sure whether or not to keep all this in its polystyrene box or just immediately throw the polystyrene away, because let's face it, it's all going to fall apart in a relatively short time scale anyway. Let's take out what is a hydraulic power pack. So basically what we've got here, it's a hand operated hydraulic pump. What happens is you have to pump a lot on this handle here, and the actual hydraulic ram here, that just moves just a little tiny bit for every pump of the handle. And yeah, the reason it does that is because the hydraulic system is a force multiplier, so although you don't have to pump very hard on the handle here, the actual force that can be applied by this hydraulic ram is actually very high. I think for this particular unit it's up to about 10 tons. Now, just feeling this unit, not only have I said the hydraulic head is actually quite heavy, and yeah, I don't find that particularly manageable. It's kind of a lot heavier than I thought. and also it's connected to the hand pump here with this hydraulic hose, and the hydraulic hose itself isn't particularly flexible. I mean, hydraulic hoses never are super flexible, but because it's kind of a short hose, that magnifies the problem. So when we come to use this, I don't know whether that hose length and the stiffness will be a problem or not. We'll have to find out, I guess. Well, I've just gone ahead and I read the instructions that came with our hydraulic punch set, and I'm afraid that they were actually, as you'd probably expect, in that rather badly translated Chinese to English, and they contained absolutely no useful information whatsoever. But I've just been playing with this, and I can think what my mistake was. You would assume that the actual position to operate the equipment was on, so I actually turned it to the on position and started pumping, and nothing happens. So as you can see, absolutely nothing happening. We're getting no movement on the ram here. What you actually have to do is you've got to turn it off. And hopefully you can now see that the little ram here, the mandrel, is being pulled down into the hydraulic cylinder. And then when you do turn the control to the on position, it allows the hydraulic pressure to be released, and the ram itself is sprung and returns back to its neutral position. Well, and typically for me, I seem to have started the video and I've gone off half cocked. So what this hydraulic punch set is for cutting circular, or in fact even square holes in metal cabinets. So for example, if you can imagine the metal chassis of a valve radio, that would typically have a number of holes punched into it wherever you need a valve base. Now if you do want to arrange to put some holes in a metal chassis or a panel, there's quite a few different ways you could do that. Probably one of the most common ways that we've all done is you can simply use a drill like this. So for small hills, a drill is probably the best, simplest option. We've all got drills, haven't you? But the problem with using drills is, especially if you're trying to drill into sheet metal, as the hole that you need to drill gets bigger, for example like this one, this is a 12mm drill, what tends to happen if you try to drill in a piece of sheet metal is you don't end up with a round hole. Usually the drill kind of bites into the metal as it starts to pull through the panel, and it quite often ends up being pulled through, and it kind of cuts a triangular hole, and it rips the hole up. Now there's various things you can do to get around the fact that this big drill will make a ragged hole in sheet metal, but that doesn't get away from the fact that it can be quite awkward to do. So again, the bigger the hole gets, or the thinner the metal gets, the more unsuitable a traditional twist drill becomes. So the next and probably the most popular solution for cutting holes into sheet metal, and especially larger holes, is the use of what they call hole saws. And here I've got a selection of hole saws here. So you can see that a hole saw really is quite a simple device. What somebody's basically done is they've taken a hacksaw blade and they've actually folded it, or they've rolled it into a circle. So this is just a kind of a tube of metal, and on the perimeter of the tube of metal we've got some saw teeth. And what you would do is this goes into what they call a mandrel, which consists of a drill point here, and the drill actually goes into the work, and this is used to centre the hole saw, so it doesn't really do a lot of cutting, it's just used as a centering device. So you put the tool into a drill which will actually spin the hole saw, and these teeth will rub against the work and cut into it, and what you end up with is a hole cut out of the sheet of metal. But the problem you can have with hole saws is that you do find that these teeth wear out relatively quickly, especially in harder materials, and you do need a drill that turns really slowly. The problem with most modern electric drills is they actually spin too quickly, and the speed at which these teeth rub across your work, it makes the teeth heat up, and it blunts them. So you need to run these hole saws with a very slow electric drill, and that's something that not everybody's got. Now these things, I always think they work perfectly good in softer materials like wood, but I've never found them quite so effective in hard materials like metal. But it certainly is an option, and it is a popular option. Now another very popular method of cutting holes in sheet metal is to use something like this. Some people call these a cone cutter. I think you can also call this a step drill cone cutter. But basically what you do is, again, you actually put this in an electric drill, and it's got various cutting edges in different sizes. So I can see that this one ranges from about, I think that's about 4mm all the way up to 20mm, whereas I've got a bigger one here. Unfortunately this one is detailed in imperial, but this goes from 1/4 inch all the way up to 1 inch and 3/8. But again, one of the problems with these is, as you start to want to drill a larger diameter hole, what you'll find is you have to run the drill a little bit slower, and also you definitely want to run these things with some oil on them, some cutting lubricant, because again, what you'll find is the cutting edges on these are relatively small and they can wear out, you know, quite quickly, especially if you're trying to drill harder materials like stainless steels. Now, as with all things, these step drills or cone cutters, they come in a great range of qualities. I've actually bought some of these in the past from China very, very cheaply. They've worked fine. I actually paid a lot more for these. You can see that these are slightly kind of a dark bronze colour. These were quite expensive. I think they came in a set with 3 or 4 for about 20 or 30 pounds, whereas these were cheap, just a couple of pounds. Well, I actually found that the expensive ones seem to go blunt and dull really, really quickly, whereas these really cheap and nasty ones that I paid just a couple of pounds for seem to have lasted me for really quite a few years. So again, unfortunately, sometimes price isn't a great predictor of whether they're good or not. Of course, you can go to reputable tool sellers as opposed to just buying them cheaply on Amazon or eBay, which is what I tend to do. But I guess with most things in life, you probably get what you pay for, don't you? Or maybe not. Now finally, we're actually going to talk about these punches. So these are actually a manual version of the hydraulic punch set that I've gone ahead and purchased. So in the case of the manual versions, what you actually have is you've got a 2-part, I'm going to call these, I would call it a die. Comes in 2 parts. You get a circular part here, a ring, and you get the actual cutting edge here. And what happens is you sandwich the piece of metal that you want to cut between both these parts, and then they get pulled together like this. And actually, they're not cutting like a drill or a hole saw is. It's actually a shearing action. It's like a pair of scissors. So these punches actually shear a hole out of the metal. They don't cut metal, they shear it. It's not the same as using a drill, where the drill converts metal into swarf. This is a shearing action. So for these little punches that I've got here, the way you actually pull these things together and deliver the shearing action is you put a bolt through them like this, and you have to also put the hole through the piece of metal that you want to cut. So you assemble them together like this, and then what you do is you keep tightening this bolt, and as you tighten the bolt, it pulls the 2 halves together and it shears a hole out of the piece of metal. You can see that these are well lubricated because I keep dropping them, unfortunately. And of course, these hole punches come in a variety of different sizes. This one is one that I use for drilling out panel controls, because this is a standard size, 22.5mm. So a lot of industrial controls, push buttons and lights, they are 22.5mm diameter. Also got some bigger ones here. Here's a 1 inch and 3/8, and got another one there which I can't actually see what size it is, but they come in a variety of different sizes. As these punch sets get bigger, the actual force required to actually pull these through the metal gets greater and greater. So this is a little tiny one. This will take relatively little force to punch a hole in a piece of metal, but this great big one here, this will take a considerable amount of force. And as I say, you deliver that force using something like a spanner. In this case, it's a hexagon key, and yeah, it can actually be quite hard to do. So again, we'll give an example of using these as well. Well, let's just have a go at using those various techniques to try to punch a hole into this piece of metal. Now, this piece of metal I've got here, this is actually come from the front of a panel or a junction box. So this is the typical type of thing that you might be drilling with these hole saws. So the first way that I'm going to have a bash at doing it is I'm going to have a bash just using a hand drill and a selection of drills getting larger and larger. I think what the size that I've chosen is we're going to go to about, let me just check what this is. I think it's about 7/8 of an inch. So that's the holes that we're going to be aiming for. So first of all, let's try and have a go using twist drills and, you know, see what kind of a mess that we make. Now there's going to be no kind of finesse involved in this. Literally, I'm just going to try and bang this through as quickly as I can. Okay, we're up to about 12mm now. On to our final drill, which unfortunately is quite a little bit bigger. And as with most things in life, everybody has a little bit more fun if we use a bit of lubricant. Slow it down. Well, having made somewhat of a song and dance to say that you shouldn't use twist drills to drill a large hole into a piece of thin sheet metal, our actual twist drills seem to do a pretty good job here. I can see that there is a little bit of a folded over edge and a little bit sharp and deformed around the hole here. Now the hole isn't absolutely circular. It does look as though it's slightly oval, maybe in this direction. So it's not a perfectly round hole, but it's actually better than I expected it to be. But I do think it's worth warning you all that when you do use a relatively powerful drill like this DeWalt, and this one has got a geared motor on it, and it can actually run at low speed. When you actually put it in low speed, if this drill was to get jammed, and they very frequently do get jammed in thin metal, what will tend to happen is the drill will spin round. And I have actually been injured in the past where I've been trying to hold on to a drill like this, and I actually injured myself using a hole saw. But you can find that there's an awful lot of torque here, and if the drill bit gets jammed and the drill spins like that, it can actually hurt your wrist. So again, really, if you're drilling holes in bigger panels, well, or sheet metal, of course it's much better to use something fixed like a pillar drill. But unfortunately you can't always get the piece of metal or the panel under a pillar drill, so you end up doing it freehand like this. So yeah, be warned that if you're using big drills and hole saws, yeah, you can really hurt yourself if you're not careful. Okay, so the next hole that I'm going to drill, I'm going to do it using our hole saw. Again, I'm trying to brace my body against it because if this thing does get stuck and jam, the drill will try to spin. So I'd rather it hit me in the fat belly than it broke my wrist. So I'm going to just brace myself a bit. Okay, so the first thing I did there is I was drilling a pilot hole. So this pilot hole is used to centre the actual cutting part of the hole saw. So you always need to drill this centering hole first before you use a hole saw. Well, as you can see, the hole that I've cut with my hole saw was actually quite a lot bigger than the one I did with the twist drill. That wasn't particularly intentional, it's just the way it's worked out. But hopefully you can see that this hole that's been cut with the hole saw, it's definitely round as opposed to slightly ovoid like this one. And although there is a little bit of chewed up metal around the edge of it, certainly there's nothing like the amount of chewed up metal that there is on the twist drill hole. So I'm sure you can see that the hole saw has done a much better job, and the actual process did feel a lot more controlled. It didn't feel as though the drill was going to get jammed at any point, although I have actually got hole saws jammed, and again you can injure yourself. So again, as the holes get bigger and bigger, the more is the tendency for the hole saw to jam, and the slower that you need to be cutting. Okay, so now we're going to have a go with this step drill or cone cutter. And again, lubrication is your friend. Okay, I don't know if you can see it's starting to smoke as the hole gets bigger, so we need to slow the drill down a bit. Okay, I've just noticed that the hole that I've drilled using my cone cutter is not actually as big as the one I did with the hole saw. So let me just get a bigger hole saw and just make this one a little bit bigger. think our cone cutter has actually done a relatively good job again. Although I do think there is a little bit more swarf and a little more galling than I actually got with the hole saw, so I'm actually surprised about that. But really, not a bad job at all. It certainly is a nice round hole. So we're now going to move on to this punch cutter, and as I said earlier, what we actually have is we have a male part and a female part of this cutter, and the two halves of the punches are actually pulled together using a bolt, and you need to put something like a spanner on the edge of this bolt because it's actually the screw thread that puts the force onto these two dies, pulling them together. So it doesn't really matter which way around you assemble them, but what I'm going to do is I'm going to do it like this because it's probably easier if the bolt head is on the front, which is where I'm facing. I'm also just going to put, again, just a smear of lubricant onto here. So I'm going to install the male part on the back of the panel. And I'm going to use a ratchet on our bolt here to actually draw the two parts of the punch together. So this is the hole that we've just put in using our punch tool, and certainly this is absolutely beautiful. The quality is much better than these other three holes that we've put in. It's actually got very little swarf or waste material around the edge. It's absolutely perfectly round, and although it is a little bit sharp on the edge, it's certainly a lot less sharp and is going to require a lot less cleanup than, for example, the other holes that we've drilled. So I actually think that the punch, definitely in terms of quality, produces the nicest job. So the last hole that I punched, that was actually 22.5 millimeters using this punch here. But I've actually got some bigger punches. The largest one I happen to have at the moment is about 35 millimeters. So what we're going to do is we're going to have a go with this. But what we are going to find is, because the actual area of metal to be removed is much bigger, because this is 34 mil, it's got a bigger circumference. It's going to take a lot more force to actually close this punch set up. So I've gone ahead and I've drilled a hole. Now, strangely enough, even though this punch is bigger than the previous one, this actually uses a smaller diameter hexagon head bolt to actually draw the punches together. So we've got to use an Allen screw here, but we'll use one on a ratchet. Now I'm having to put quite a bit more force into this now. I've got to admit, it's not too bad though. Now, it definitely did take a little bit more force to actually pull these punches together. Certainly this bigger hole took more work than the smaller one over here, but as I'm sure you can see, we've got another absolutely beautiful pristine hole that really isn't going to require hardly any cleanup. There's just the slightest of burred edges on here. Now, I think one of the reasons that I was able to actually punch this even large hole through with relative ease is because I used a little accessory which doesn't necessarily come with these punches. I actually used a little bearing surface, a kind of a little roller bearing, so let me just show you that. Now, if you're using these manual punches with a drawbar bolt like this, what you really want to do is you want to go ahead and you can actually purchase these little bearings here. So otherwise, if you don't use the bearings, the actual head of the bolt here, it rubs against the back of the punch, and as you tighten that up, you get more and more friction between the bolt head and the back of the punch. So the tighter it gets, the more friction you get, the harder it is to turn. So this little piece of metal here, it's actually a bearing, it spins. So if you actually sandwich this bearing between the back of the punch and the bolt, it makes it very much easier to actually turn. So if you are going to use these hand punches, I've just demonstrated they're perfectly fit for purpose. Definitely go and find yourself one of these little bearing accessories. It makes the job so much easier. Now, some of you might be wondering where this piece of metal has gone to. Now, of course, where it's gone to, it's actually now just trapped inside the female part of the punch. So there it is. So the beauty of using a punch is it actually removes a tiny amount of metal. You know, unlike drilling it with a twist drill where you've actually got to convert the entire surface area of the metal. You've got to convert all that into swarf to break it out. Whereas if you use something like a punch, unlike the other cutting methods, if you use a punch like this, because it's a shearing action, it produces a very, very high precision, a perfectly round hole, but you're not actually cutting a lot of metal. You're only kind of cutting the metal around the very, very perimeter. So it's a much more efficient process. Now, as I mentioned earlier, this 35mm punch, it does actually come with a hex bolt on it. So typically you'd probably use something like an Allen key to actually tighten the two parts up. Again, I would dissuade you from using an Allen key. Again, because you've got to put so much force on here, it can actually really cut into your hand and be quite a miserable process. So if you can use something like a ratchet or a long handled spanner, you'll find the whole process, again, it goes a lot easier. The last thing you really want to use is a little Allen key here, because you just don't get enough leverage on the length of the bar here, and it just ends up really hurting your hand. So definitely save yourself some trouble, and if you're using one of these, use something like a ratchet or a big spanner. So let's return now to our Katsu hydraulic punch. Now, the actual punching dies, they work in exactly the same way as the manual dies, which I showed you with earlier, but rather than using a draw bolt to actually pull the male and female parts of the dies together, it uses a hydraulic cylinder to actually do that. So in theory it takes all the work out of it. So I'm not sure if these, yeah, okay, so this has got the size written on it. So what does this one say? Okay, this is 27.5. I think there's actually a smaller one than that. Okay, so the smallest one the set comes with, that starts at 22mm diameter, and it goes all the way up to, let's have a look. So it goes all the way up to 60mm in diameter. So if we actually compare that, so hopefully you can see this will cut considerably bigger holes. And as I mentioned earlier, because the circumference of these cutting edges is so much greater than some of the smaller dies that we used, this is going to take considerably more force to actually punch the hole through our metal. And I suspect that a punch of this size, you probably couldn't do it using a hand tool. You probably do need some assistance in the form of the hydraulics. So I think rather than messing around with all the small hole cutters, I think we'll just jump in and let's try using this big one. Well, believe it or not, our hydraulic punch set does come with 3 sets of instructions, which are all identical and about as much use as a plastic bag to a 2-year-old. Now, not only do these instructions contain perhaps what is some of the worst spelling and grammatical errors I've perhaps ever seen, but beyond that, whoever wrote them seemed to manage to convey absolutely no useful information whatsoever. But I guess on the plus side, that really has saved us the time and trouble to have to bother reading them, which we don't like doing anyway. So here's our hydraulic ram, and what we need to do is, I'm guessing we need to take this male mandrel and screw this into the end of the ram. Now, both of these screw threads at each end, they seem to be the same screw thread, but this one seems to have more thread engagement and is a little bit deeper. So because of the depth of the thread, which is in the hydraulic cylinder here, I'm guessing it goes this way round. Although I've also noticed that it's also got a thread on the inside, which I'm guessing is to some form of thread adapter, so you can reduce the size of the mandrel and use it with the smaller punches. So I'm guessing it's something like that. So yeah, this will actually fit either way around, but I think I'm gonna put it in that way around, seeing as it doesn't bother to tell us. And then we need to take the female part of our punch. I can feel it's got a relatively sharp edge on it, which is what we want. Slip that over there. And then what we would have to do next is we need to take the piece of metal that we're going to cut and sandwich it on either side of our punches, with our mandrel here going through a hole drilled in the middle. Now, it does look like the actual hollow mandrel here is actually quite a thick shaft, so I'm guessing that we're going to be putting quite a lot of force onto these punches. And actually, the piece of metal, when we try to cut our piece of metal, we're actually going to have to drill a fair sized hole in it first, just to get the mandrel through it. So I've got to admit, it does seem somewhat funny to have to use a hole cutter to make a hole for a hole cutter, but there you go. just see if that's big enough. No, not quite. Oh, and that's what I meant about a drill jamming. So I have gone ahead and I've put a little bit of lubrication on the male part of our hole punch, and I'm going to screw this onto the mandrel. And tighten it as much by hand as I can, because that's going to save the amount of hydraulic pumping that we need to do. I'm hoping you can see that when I start to pump the handle, the male part of our punch here, it gets pulled through the face of our piece of sheet metal that we're going to cut the hole into. So let me pump a bit more. Okay, I have to say that certainly at the moment the hand lever that I'm pumping here takes absolutely no effort whatsoever. It is effortless. Oh, I think that was it. That was somewhat of an anticlimax. Well, that's just too easy. Well, as you just saw, we were able to punch out what is really quite a big hole in just a few seconds. Wow, that really couldn't have been any easier. In fact, the most difficult part of the whole process was actually just cutting the hole in the middle of here for the mandrel in the first place. And of course, like our smaller holes that we punched, this hole is absolutely perfectly round. And although again it's got a very slight burr on one side where the die got pulled through, so this side is smooth, but on the opposite side I can just feel with my finger just the slightest burr, so it would need just a little bit of a clean up with a file. But what a perfect hole, so that gets an absolute 10 out of 10 for ease. So let me go ahead and just release our hydraulic pressure now. And will this just come off? Okay, that is stuck in there just a little bit. Let me get something to tap that out with. And there's our disc of metal. And again, you can see that the disc that we've removed here, it is actually pretty much a perfect fit. You could probably get this piece of metal to go back in here, and because it actually trims away such little wall thickness when it actually cuts through here, it's just an amazingly efficient cutting process. I've got to admit, I'm definitely going to give this tool a 10 out of 10. It certainly did a great job on that. So the piece of metal that we've just punched our hole in here, I think it's probably relatively thin. I'm not sure if we can just roughly measure the thickness of it. Fortunately, it has got some paint on it. Let's see if we can get a measure on the edge of there. Okay, this is coming up as about 1.3 millimeters, maybe 1.4. So again, relatively thin. Now in theory, this punch set can go up to about 3 millimeter. So I think what we need to do is we need to push it to the max and have another go in a thicker piece of steel. So let's do that. Well, as you can see, I've gone ahead and I found another piece of sheet steel which is considerably thicker. This one is about, yeah, that's 2.5 millimeters. Certainly feels an awful lot stiffer. So let's see how our punch gets on this stuff. Now again, I expect the hardest part of this process is probably just going to be drilling the hole to get the mandrel through. So let me go ahead and do that. So even just going through that with a twist drill was relatively hard work. So I don't know how we're going to get on using the cone cutter. Again, let's find out. Well, okay, let's get pumping. Well, I can feel I'm having to put a little bit more force now on this hydraulic pump. But I've got to admit, it's still not difficult. Oh, that's feeling a little bit tighter now. And I think that's just burst through. Okay, another absolutely perfect hole. And let's see if we can retrieve our disc of steel. Well, as you just witnessed, it did actually cut through this 2.5mm of steel absolutely effortlessly. Now when it comes to purchasing one of these hydraulic punch sets, you can pretty much pay almost as much money as you want to. Now one of the most famous manufacturers of punches and dies is a company called Greenlee, and certainly I've bought from Greenlee in the past, and the quality of their products is absolutely second to none, and a set of Greenlee punches will last you a lifetime. But the problem I find with Greenlee punches, well, it comes back to maybe you get what you pay for, in that unfortunately they are just very, very expensive. I had a look online and I note that they do various types of hydraulic punching tools, but you can easily pay £1,500 or more for a hydraulic punch set, whereas this set costs just £69. So in terms of value for money, well, I think it's absolutely incredible. Of course, we don't know the quality of these dies, these punches. I don't know how long they will last. We don't know, how good the heat treatment is on them. But I suspect that, if you're just a hobbyist like me, you are never going to pay £1,500 for a Greenlee hydraulic punch. But perhaps you could afford to shell out and pay £70 for one of these Katsu hydraulic punches. I think that the only complaint that I've got so far is just the quality of the instructions. It's just, well, the instructions are just non-existent. You really do have to work it out for yourself. So I think what I would like to try to do is, I would like to try to use some of these smaller punches, because we've used the biggest, so we've pushed it as far as we can. So let's try and use one of the smaller ones here. Let me just see what this one is. That's a 27.5. I think let's try and find the smallest one just out of interest. So what's this one? Okay, here's a 22. Now looking at the 22, I can just see that the actual mandrel which is installed here in the hydraulic ram, that isn't going to fit through the centre of our punch set here. So it must be necessary to adapt this in some way. And again, without the instructions, it's not particularly obvious, so I'm guessing that that is the correct mandrel. We did notice that this one had a hole in the end of it, so I'm guessing that this is going to screw into here. Is that going to screw that way on? Maybe that isn't the right way around. Let me try the other way around. Just notice that the thread seemed to bottom out, so let's try it this way around. Okay, maybe that goes like that. So again, this can only screw into here. So I'm guessing this is now where we need our spacers. I've got to admit, I don't really like this arrangement. It seems needless. They could have actually built some form of step shaft. It wasn't really need to screw these two mandrels together. They could have actually made a mandrel that was thinned out towards the end, but had a thicker section that would actually screw into the hydraulic pump here. So the only reason I can assume that they've done it like this is purely for reasons of cheapness. I think if I was going to keep this, which I am going to do, I think what I'll do is I'll go ahead and in the lathe I will probably make my own mandrel, which will step down from this relatively thick section here that screws into the pump to a much thinner section, and then we don't have to use what I'm guessing these spacers are for here. That's just a little bit clumsy and it makes the whole tool a little bit bigger. Okay, so yeah, it looks as though it's going to go together like that. It just seems to me quite poorly thought out that you've got to use these collars here just to space everything off. It just doesn't really seem to be necessary or the best way to do it. The actual length of the whole tool now has just got that little bit greater, and it's just made it all, again, it just feels that little bit more unmanageable. So having cut the largest hole possible in a relatively thick piece of steel, I think I'd quite like to experiment with some different materials. So I've got some PCB material here. So this is a 4-layer PCB. So this is going to be a glass reinforced fibre circuit board. So it'll be interesting to see whether or not we can punch through this, or if the material, it may just shatter. I'm not sure. We'll give that a try. I've got a piece of aluminium here, that's just over 3mm thick. Got some brass, which is 1mm thick. And I've got a piece of plastic here, which again is just over 3mm thick. And just for giggles, I've also got a piece of plywood here, which is, well, that's 4mm thick. I've got no idea if we can use a punch in plywood, but again, we'll give it a try. Now I think we'll try and use a different mounting arrangement this time, because I did have some trouble actually supporting this last time. So let's mount the actual hydraulic ram in the vise. Here's a securing nut, and let's tighten that down. And let's give the handle a pull. Well, didn't really feel any resistance whatsoever there. It went through absolutely effortlessly. So we had no problems whatsoever just punching through this fiberglass circuit board, but I'm afraid I do seem to have got the actual male part of the punch that's just a little bit stuck. Oh god, it really has got that tight. There we go. So I think that I'll try our piece of 3mm aluminium plate next. Yep, and that's gone through. And again, just looking at the quality of the hole in the aluminium, well, again, absolutely perfect. So let's go ahead and try our 3mm of plastic sheet. Not sure what type of plastic this is. It is a relatively soft one, so I'm sure that our punch here will go through this like a hot knife through butter. Let's get pumping. Okay, I think that's through. Took absolutely no effort. Yeah. Oops. Oh, that's rolled off to the opposite side of the garage underneath the car. Bah! Ooh, looks like I might have a bit of a leak on my diff somewhere. Damn it! You know what, I really think I should come under here more often. But yeah, again, perfect, beautiful hole. Okay, it's humpy pumpy time. Again, through, absolutely no effort whatsoever. So it does feel like maybe in some of the softer materials, the actual punch has more of a tendency to kind of jam itself in there, but I'm sure it's not a big deal to get it apart. Yep, this time it does seem to have got hold of that quite tightly. Again, absolutely perfect, buttery smooth, perfectly round hole. So I'm going to go ahead and I'm going to play my joker next, and we're going to have a go in a piece of wood. And as you can see, the 60mm hole punch really hasn't done a bad job at all. And I think the splintering that you can see around the edge here, that's where the grain has broken out when I actually put that cone cutter drill. The actual punched edge I think is really pretty good. Now this is a piece of plywood, so it does have some grain running in kind of opposite directions. But I suspect if you was to use this punch in a material like MDF, I suspect it would probably go through a lot better and probably leave an even neater hole, but I don't think there's anything wrong with that. So in summary, what do I think of this Katsu hydraulic punch set? Well, as I said earlier, at £69 I think it represents absolutely outstanding value for money. Now as you've just witnessed, this punch set really has no trouble whatsoever going through a whole range of different materials and different thicknesses of materials, and we can go from really quite small punches here M22 all the way up to 60mm, and it punched all the holes in a whole range of materials very cleanly and absolutely effortlessly. What are the downsides of our punch set? Well, one, the instructions are utterly garbage and of no use whatsoever, so you've got to kind of figure it out for yourself. I would say that the actual hydraulic head here, it's considerably heavier than I thought it was going to be. I don't know what I was expecting, but it is heavier. And again, I mentioned earlier that this hydraulic pipe here, it's very stiff. They could have actually used a much thinner pipe because we're not actually moving very much oil here. So yeah, if you're going to use this a lot, I suspect you'd probably go down to a hydraulic company and get them to make you a new flexible and perhaps a longer hose, because I think that would work a little bit better. But yeah, the head itself is really quite heavy, and I could see that this could be quite awkward to use in some situations. But of course you can go ahead and do what I did and just grab one end of it in a vise, and of course it does become much easier and much more controllable. Now, would I recommend you to buy one of these hydraulic punch sets? Well, yes and no. I think what I would say is if you've got a need to punch big holes, maybe 60mm like this one, 60mm and above, I definitely think that the mechanical advantage of the hydraulic system is absolutely great. You would really struggle to use a cutter of this diameter or even bigger just using normal hand tools, using spanners and hexagon keys to try to wind this through a piece of steel plate. You'd probably find it pretty much impossible. But what I would also say, if you're only cutting relatively small holes like, I don't know, M20, 22mm like this one, maybe up to 30mm or even a little bit more, it's actually not very difficult to do it using either a cone cutter, a step drill, a hole saw, or even just the manually operated punch dies that just have a drawbar and a bolt through them. As long as you use something like a long-handled spanner, I don't think you would have any problems. So I think whether you purchase one would be very much down to the type of work that you're doing. So just to re-emphasise that, I think if I was doing smaller work, you know, holes around M20, M30, I probably wouldn't bother with the hydraulic punch. It's just not necessary and it's too cumbersome. But if I was going to be punching big holes like this on a relatively frequent basis, I really wouldn't hesitate to pay £60 for this set. So overall, I think I'm going to give it an 8 out of 10. I think it's a good product. I paid for this myself with my own money, so I'm not being sponsored to say that. I think it's a good product and I would recommend it. But I think for today, that'll do. So it only really remains for me to say, as always, thanks very much for watching. And until next time, bye-bye for now. Bye-bye.
Oh, that's the way to do it.